So, yesterday, if you were absent, you're going to watch the video later to catch up. But yesterday, we talked about what a solid is. What the heck is a solid? We defined it. It's right there. Again, you can watch the video later. We also talked about the name for these corners. There's a fancy schmancy name for these corners. Mr. Horton, what was it? Those corners are called what? Vertices. Where two faces meet. Look at where my fingers are at. Where two faces meet. Moreno, what are these called from yesterday? Thank you, Moreno. All right, no worries. Gonzalez, what are these things called where two faces meet? They're edges. And then the faces are actually the two-dimensional shapes that make up the solid. So we had 5 triangles here, 1 pentagon at the bottom. Those were called faces. Again, if you were absent yesterday, you'll copy that later. I'm just kind of reviewing. Let's go and swing down to the second shape here on your notes. Go to write half a sphere. We'll write this. Half sphere. Sphere. The PH is an F sound. A sphere. We'll write that down. Submit it on. Yes, hold on.
No.
Right here, it's on the phone. We'll grab it. So half a sphere. Now, notice the bottom. What shape is this bottom face here? Close.
Okay, go on.
What do I write? Circular face. Circular face. Want to do that in your notes? A circular face. Now, if I wanted to find the surface area of this half dome, this half sphere, it's like a domed surface. Look at that. How will I find the surface area of this? It's not made up of flat rectangles like we did yesterday. Right? It's not made up of flat surfaces. It's kind of easy to find the surface area. But how am I going to find the surface area of half a dome? Well, if you look at your reference sheet here at the bottom, all the 3-dimensional shapes, go all the way down to the bottom. It says sphere. And you can see a surface area formula there. It's capital SA. And the surface area formula for a full sphere, in other words, if I imagine a full sphere here, look at it. A full one would be, it says here, 4 pi r squared. Write that down. But we're dealing with half a sphere, so what should we do with that? Change the 4 to 2, or just divide it by 2, which would change the 4 to 2. I like that word. I like the way you think it. So look what I got. If I wanted to find the surface area, which I'm not going to do, I'm just talking about if I wanted to, I would use this formula, 4 pi r squared, and then I'll divide it by 2 because I'm only dealing with half a sphere. So right now I just want you to just be aware that, like, hey, look, there's some formulas in front of you that we're going to use in the very near future. So far, so good. We're not going to calculate the surface area, but I just want to bring some attention to the fact that there are some surface area formulas that you're going to start getting familiar with very soon. Here we go. Next one. Look at this front face here. What kind of shape is this? Close. Close. 6-sided figure would be a hexagon. Notice, I got a hexagon face in the front, and on the other end, I got another hexagon face on the other side. Whenever you have a solid with two faces exactly the same on either ends, that solid is called, ready, you're going to write this down, a prism. A prism. What makes a prism a prism? Well, go ahead and put an arrow on the front face and an arrow on the back face, and put 2 faces are same at both ends. That's what makes a prism a prism. So that's what makes a prism a prism. Would that last shape at the bottom of your paper, would that be a prism also?
No, sir.
Argument, please. Why is that not a prism? Is there two faces at both ends of the thing? So that would be a prism too, huh? So go to write prism here. What kind of shape is this right here, this front face? Ramirez, one more time, hit it. The trapezoid. So, what's the difference between this prism and that prism? So that's beautifully summarized. So that's how we're going to name the prisms. There's different prisms. There's different kinds of prisms. The one right up here, you're going to write with me in parentheses. Oh, you don't have to put parentheses. Put hexagonal prism. What would I call this one then, Hernandez? Nice. Polish it up one more time. Nice. Someone fix it. What would I call this one?
Prism.
Trapezoidal prism.
That's what I said.
No, you said trapezoidal. And I want you to polish it so it's
Wrong.
I want you to polish it so it should say trapezoidal. So that's good. I like your thinking. It's all good.
Okay.
Here we go. Trapezoidal. So you just name the prism by the front face. The faces that are opposite ends. Does anybody like UFC in here? Me too. What's that shape they find it? Look at 1, 2, 3, 4, 5, 6, 7, 8. They make an octagonal prism. There's a front face. Right? I'll make dotted lines to get the 3D effect. So you're dealing with an octagonal prism here, right? So I'll make it fun of it.
That's a good thing.
So,
perhaps they will octagonal prism.
thank you, Hernandez. Octagonal prism. How about this one? What would this one be called? Moreno? What kind of prism would that be? Triangular prism. What would this one be? What shape is this? So that's it.
Right. Is that right?
That's a rectangle, but what kind of prism would it be? Rectangular prism. Rectangular prism. Triangular prism. Octagonal prism. Trapezoidal. Hexagonal. So you just name it by that front face. We're rocking and rolling. Only one example. Only one example today. Ready? You're going to flip your page. Example 1. That's all we're doing. Okay. Example 1. Only one example today. Here we go. Going to copy down this prism if you can. Watch the master draw it. What I do is I like to draw the top face. Look at the top face. And then the bottom face. Look at, there's your rectangles. And then I just connect the vertices. Look at it. If you want to add some 3D effect, just make it a dotted line. We'll do that again. Watch the master. Watch this.
You need to cut the line. At least do that.
Are you making fun of me, Hernandez?
Very nice.
Oh, look at that.
Mine came out better.
Are you sure?
Robots are
You make it put on my thing, come on, stop.
Mister, I think I messed up on it.
Later. So, what kind of prism do we have, by the way? Rectangular prism. There's a rectangle in the front, rectangle in the back, they're exactly alike. Or if you wish, there's a rectangle on the top and bottom that are alike if you, right? There's both the ends, or the side and side. However you want to see it, it's a rectangular prism.
But if it was square, it would just be a cube, right? So why do we get the square and then cube with the other cube and then prism?
Fun.
What do you mean? Just explain it.
Ready? Here we go.
All right.
So if you look at your reference sheet here on formulas, let's go and find the surface area. So we're going to write F, find SA. Surface area means, well, when I write SA, we're talking surface area. So let's find the surface area of this puppy. Now, to eliminate any headaches, to eliminate any stress and anxiety on your part, please pay attention. The top two three-dimensional shapes, one says rectangular prism, and then underneath it says general prisms. When it says general, that means octagonal prisms, trapezoidal prisms, whatever prism you're dealing with. What we're going to do is we're going to use the surface area formula for the general prisms, not the rectangular prisms. The surface area formula for the rectangular prisms will needlessly get us into some discussion that's going to be a waste of time. It gives you some long formula for rectangular prism. So we're going to ignore the rectangular prism formula and use the general prism formula, which says, if you read it, it says sum of the areas of the faces. In other words, the surface areas add up areas of all faces. That's it. How many faces are there, Gordon? There's 6 faces. Guess what, ladies and gents? We're going to find the area of all of them and add them up. That's it. But the top and bottom are the same, right? Fernandez, let me talk. Thanks. The top and bottom are the same, so all I got to do is find 1 and multiply by 2. And then what's the other one? Moreno? Look at front and back. I look at the front and back face are exactly the same. I'm going to color code mine. And then the left and right are exactly the same. I'll put this one in green. The right rectangle, left rectangle, word business. Seriously? Here we go. Oh, excuse me. Sorry. Here we go. I'm going to find the top and bottom faces first. So go on your notes. So you're on the other side now. I'm going to put top and bottom. We're only going to do one example today. Top and bottom faces. Just got to be a master forward.
Mine's not really artistic.
Here we go. Gentlemen, let me talk. Thanks. Area formula for rectangle, Mr. Ramirez. What's the area formula for rectangle? What's the area formula for rectangle? Mr. Ramirez. What's the area formula for rectangle?
Wait, what did you first say? Can I help you out, Mr.?
Yeah. No, hit it. Makes sense with it. So, look at the top and bottom face. They're rectangles. I'm going to find the area of one of them and multiply it by 2. So the length is 8, the width is 7. We're rocking and rolling. 8 times 7 is the area of the top face. Help me out, one of them. So the area then is 56 chickens, horses, or termites?
Chickens.
Square feet. And there's 2 of those puppies. So I'm going to multiply it by 2 because the top and bottom are the same. So watch this now. 56 times 2, that's going to be 112 square feet for the top and bottom for rocking and rolling. Wait. Are we done?
No.
All I've done is found the area of the top and bottom face. Chill. Now we got, nice, we got the left and right, which I'll do in green now.
You have to multiply 112 by 2, no? Since I think there's 2 sides. No, that's
Wait, but 112 is this the square feet of the top and bottom?
Oh, no, you already multiplied by 2, my bad. I just saw.
Okay, got you. So here we go, now left and right faces here. I'm going to put mine in green to write this down. Left and right faces. Left and right faces. What kind of shapes are the green rectangles? What's the area formula for rectangle? Rock and roll it. Look at the green. Length is 12. What's the width here?
8.
Careful. 7 up. Careful there. So
7. Oh, never mind.
yeah.
Yeah.
So 12 times 7 is the area of one of the rectangles. I never memorized my 12s. Help me. Please
84.
do the math.
And on screen, I think is
84 chickens, horses, or termites. Times 2. There's 2 of them. Square feet. So then we got the left and right. Question so far. We have top and bottom in black, left and right in green, and now we're going to do the front and back faces in blue.
Again, left and right the same as front and back.
Would someone like to answer that?
No.
Argument.
Wait,
Wait, what else got the argument? Then we'll argue. Nice. Look at this 8 here, right?
Yeah.
So they're not the same. You're going to say the same thing, right? Indeed. Ollie, is everything okay? Thanks, Ollie.
I'm sorry, man.
Stop learning. Front and back. Yeah. Front and back faces. Area of the rectangle's length times width. Want to know what's the length and width of these rectangles of blues? No. What's the length and the width? Nice. We're rocking and rolling. 12 times 8. 96 chickens, horses, or termites. Times 2. We're rocking and rolling. All right. Front and back in blue, left and right in green, top and bottom in black. We're now ready to write the surface area. In red. Love it. Question so far before we write the surface area. So surface area, SA, is top and bottom is 112 square feet. Left and right is 168 square feet. And then front and back is 192 square feet. So we got 112 plus we got a whopping surface area of 472 chickens, horses, and termites.
P squared.
Questions? Nice. What's this?